So my name is Sylvain Michaux. I'm a first year PhD student. I'm working here in the CEA, Inac, in the Department of Low Temperature. It's called SBT. And my lab is called LCF, for Laboratoire Cryogénie et Fusion. So it's a laboratory of fusion, hydrogen fusion, and cryogenics. I'm working on the cryostat that produces a continuous solid hydrogen ribbon of 1 millimeter in width and some tens of micrometers in thickness. These ribbons are used as targets for Highpower laser. When the laser hits the ribbon, it creates a plasma of pure protons at the rear side of the target. These proton beams could be used for microscale radiography or for proton therapy. And this last point is particularly inspiring because proton therapy is a good alternative to radiotherapy for curing cancer and tumors. Proton therapy is safer, more effective, but it's also more expensive and more difficult to realize, to achieve. So the idea, the goal, is to replace the huge ion accelerators in hospitals by this simple hydrogen extruder and a high-power laser. So it would be cheaper and much more easier to proceed, and it would allow a wider use of proton therapy in the world. Well, the main advantage of hydrogen is that the plasma we get after the shot is pure protons. There is no impurity, there is no metallic part, or because we can do proton therapy with metallic foil instead of hydrogen foil, but it's not as good because you have a lot of impurities that impede the beam in the end. There was only one study made for the rheology of solid hydrogen, and we do not really agree with the results. So we have to do our own research on this topic, or our own fundamental research on this topic, in order to calibrate and understand what's going on inside the machine. For now, this study about interaction between laser and proton is still at very basic level, very fundamental level. So it will take a long time before we can actually master and use proton beams, and it will take even longer before medical use of this for proton therapy. It's a long-term goal, but it's inspiring.